Hello and welcome back to our mini-series on cyanobacteria. In the previous two episodes we have covered off what is cyanobacteria and how we go about detecting it. So once we understand what's in our water, it's kind of around what we can do to mitigate against this. So I guess first question I have is, how do I understand my risk?
That is a good question.
Oh.
We've talked a lot about, the difficulty in actually figuring out what's going on with your cyanobacteria. So, in terms of a traditional risk-based approach, you really want to understand, is there a chance I will get cyanobacteria? Do I have it? And then is it the type that may potentially be quite a serious problem for my water treatment plant? So it's a difficult process, and it'll be different for every type of supplier.
Yeah, I guess what we were talking about in one of the other episodes about sort of understanding a water supply and whether that will potentially lead to cyanobacteria or has something changed in my water, and looking for whether that is actually leading to cyanobacteria present is your first step. And then if you do have cyanobacteria, it's about sort of understanding what the type of risk or the level of risk that there is. So, it's sort of how much cyanobacteria are present, and if you're breaching any of the cyanobacteria thresholds, that means you need to sort of understand that risk a bit more. And so at that point, you're sort of trying to figure out, are potential toxin producers present? If there are potential toxin producers present, then you want to know, are they actually producing toxins? And so that's when we start to look for cyanotoxin production genes and for the toxins themselves. So, it can go from sort of a very base level of, is there potential for cyanobacteria to grow in my water supply? And if you've got historical data, you might actually have really good knowledge on the potential for cyanobacteria there because you've been looking for the last 5 or 10 years, you haven't seen cyanobacteria. Actually the potential risk's quite low. Other water supplies, maybe you don't have that data, and that's where you need to start filling in these knowledge gaps. So river supplies, where people haven't been going out and actually looking at the base of the river, are there mats growing there? Sort of how much mats are present? Are those mats cyanobacteria, or are they just other types of algae? What time of the year do they actually come into play? And I think the other thing that people have been overlooking is these benthic cyanobacteria on the base of reservoirs and lakes. And so do we ever see mats coming and ending up on the shore? Do we ever get those musty aromas, the geosmin and the MIBs in the water itself, causing customer complaints? And if you've got that in combination with not seeing cyanobacteria in your water samples, then that suggests maybe there is actually benthic cyanobacteria on the bottom, and you just can't see it from where you're standing on the shore.
Yeah, it's really good to have a formalized cyanotoxin management plan, and you have the risks detailed and potential responses that you can take, and whether that's looking at the source water and what you can do there, maybe change a source if you have that option, and the treatment plant, what options you have there to treat these risks.
Yeah, so I guess that's probably what I was more looking into. Is there a framework to actually go through to evaluate your sources, and then from that determine your risk, and then out the back end of that sort of working out what you have to do, and by the sounds of things like a cyanotoxin management plan or cyanobacteria management plan? Yeah,
so the plan will cover things like understanding your sources and the risks, and having different alert levels when perhaps if it's seasonal, the cyanotoxin risks will be greater, and what responses you can take. And so you might alert certain people as part of your water supply organization to take more samples or to do more monitoring or to activate certain treatment processes. So powdered activated carbon might be an option at certain treatment plants, and that can help deal with cyanobacteria and cyanotoxins. And that's something you would run part of the year when you think the risk is greater to help protect public health.
So I guess, look, we've all heard about these upcoming water reforms, and I know the rules are changing in July 2022. So how are things changing around cyanobacteria, cyanotoxins with the changing water reforms?
I think there's a greater onus placed on water suppliers to understand source water, and the part of the reforms is clearly making water suppliers more responsible for understanding source, treatment, and distribution. And so as part of the source responsibilities, having an understanding of the risk of cyanotoxins is very important. And there are different risk categories. There's low risk, medium risk, and high risk. And as has been pointed out in the episodes, you can have different profiles of risk throughout the year or throughout even one season. So having those different alert levels and responses is very important. And as JP was saying before, you need to know how you're going to respond at different times of the year and when you have different risk levels.
Yeah, the way that the rules, as they currently are written in the draft drinking water standards, work is that if, as we talked about in an earlier episode, if you have a bore source that may be connected to a river, or you're drawing from a surface water source or a lake or a river itself, then you must establish your cyanotoxin risk. And if the answer to your cyanotoxin risk is that it's low, then you may get away without doing a plan. If it's medium, or what they call at risk or high risk, at risk being, there may be some chance of it, high risk, more likely that you do know that it's there, you have to create your cyanotoxin management plan. And at least in terms of the actual rules around once you have that plan in place, there's now several requirements which are not too different to the old drinking water standards, but perhaps a little bit more explicit that, the plan itself gets audited. You have to report any presence of, say, cyanotoxins to Taumata Arawai. There's also, as you mentioned, JP, there's limits. So similar to the drinking water standards, there are certain thresholds of species which can be used as an indicator that you're essentially in a risky situation. There's also thresholds for maximum acceptable values for the toxins themselves. But I guess to cut a long story short, the thresholds are all well and good, but using a threshold to establish that you're at risk is probably not a great idea. You kind of want to take a step back and think about, what do I need to look at in my source, and what should I be measuring? When should I be measuring it to figure out if I've got a risk or not? Because if you go and test and you trigger a threshold, it's already too late.
Yeah, you don't want to be in that situation where you're having to deal with having an actual risk and not having anything in place to actually sort of work through and mitigate or manage that risk or remove it from your consumers. And I think that's what a lot of water suppliers might be confronted with when they're sort of at that point when the new regulations come into effect, and they need to figure out whether they're at low risk, medium or high risk, and trying to sort of actually provide the evidence to say that they're in a low risk category. So I think that's where a bit of forethought from water suppliers will be really valuable to them is, I think I'm at low risk, but how can I actually prove that to Taumata Arawai?
Yes, exactly.
What evidence do I have in place that says that my groundwater supply isn't connected to a at-risk water supply? Why do I feel like my river is actually low risk? Do I have some data which I can use to back that up?
Exactly.
And I guess that comes back to that duty of care, right? It's if you don't understand what your source is like, then how are you going to know whether you're at risk? And then with that, any sort of cyanotoxins that might creep in, what do you do to respond to them? So I guess that links into that duty of care that we've been talking about a lot. That brings me on to my next question, which is is there any way that I can protect my source? And if I can't protect my source, is there any way that I can protect my water supply going out to my consumers?
Yeah, there are ways, and most of them are pretty obvious. It's just about making sure that they're being done and they're being followed. And you guys could probably comment more on this than I can, but in terms of a water source, you don't really want to be loading it up with nutrients, be it from man-made sources or say I wouldn't say it's man-made, but in a way it is. The kind of runoff problems that happen in some rivers and lakes and low oxygen environments. Healthy state of the river is better probably, but actually making sure that the source is being protected in regards to, say, limiting the use of fertilizers in the catchment, that can be quite tricky. Generally speaking, these kind of things are addressed in a water safety plan, and the water safety plan will consider all sorts of different risks that can occur in a catchment, from a diesel spill to somebody getting rid of some old DDT or something like that, all possible risks that might occur. And once you've identified that, yes, there is a risk, because, yes, there is a chance that something could happen, you'll want to put something in place that manages and hopefully mitigates that risk, but at best manages it. And how that's done will differ from source to source, council to council, because many different groups have responsibilities for different parts of these water sources. Some of them may not even have responsibility for what's upstream of their treatment plant. Maybe a completely different group with different goals and different things that they're looking for. So it can be tricky, but really the mechanism in at least in terms of drinking water is to make sure that the water safety plan is well thought out and being followed, and that there is at least an understanding of what the risks are. So and trying to put that into practice to protect the source water.
Yeah, so it's best to protect the source water if you can, but if you can't, if these things are going to make their way into the treatment plant, then there's certain processes that can be put in place. And from a treatment perspective, you're probably going to treat it the same cyanobacteria as you treat algae, in terms of what was mentioned in a previous episode, where you might have a ballasted sand approach to help sink the algae and settle them and remove them, or a flotation process to float them out and reduce the concentrations of them. But even with those processes, you may get the cells of the algae could rupture, and then if there's cyanotoxins, those can go through. And if those aren't removed upstream, then there are other processes downstream, such as advanced oxidation with UV disinfection, that can address some of those cyanotoxins. But a lot of this is like Jonathan was saying, some of these processes are only activated after you know that there's a risk. And so how you approach that and make sure you are continually minimizing risk requires a lot of historical data and understanding your source, understanding your plant. And then, of course, many suppliers don't have treatment processes that can deal with these risks. So you have to take a more holistic approach, master planning, longer term, and also take into account environmental considerations such as warming conditions, fluctuating levels in your reservoirs and in your rivers, and things of that sort.
Brett's quite right, because as we all know, there's some water sources are degraded, and they may get better over time due to various things that people do, or they may get worse. Of course, climate is one thing that will probably get worse, and changing weather conditions and all that sort of thing, which we cannot control. So that sort of thing will have some sort of effect on the source, may bring about warming conditions that create more growth, and maybe the opposite way around, more rainfall, washing it off more frequently or something like that. But the long story short is, as long as that risk has been considered, the cyanobacteria and the kind of toxins and taste and odor and the rest that they produce, they can be treated. They can be treated. So if the answer is that the risk is high and that there isn't really any practical way to deal with it in the source, then the answer can be treatment processes.
So once you define a source as high risk, what does a sampling plan sort of look like? So you know that you've got cyanobacteria present. You know they have the potential to create cyanotoxins. What would you do in terms of sampling to, I guess, have a measured approach to that risk going forwards?
So it would be at risk and medium risk and high risk water supplies which are being sampled for cyanobacteria. And in the summer months, it's more frequent than in the winter months, and that's just because there's more likelihood that cyanobacteria might be present. So it might be every fortnight in those high-risk times that you might be going out and collecting a water sample, or maybe go out to look for benthic cyanobacteria. So in a river, that might be that you've got a spot where you have previously seen cyanobacteria, observed them, or other types of sort of benthic mats growing on the base of the river.
Yes. Yep.
And it would be a matter of going out and actually sort of looking at the percentage coverage in a transect out there. So that might require a bit of training up front to be able to get the staff skilled to be able to go out and do it. But at that point, you know, you can start to easily collect your data. For benthic cyanobacteria in a river, it might be walking around the outskirts of your reservoir and trying to see if there's any mats which have floated up.
Yes.
Any signs that there might be stuff lurking where you can't quite see it.
Yeah.
Or it might be sort of monitoring for those earthy aromas through sort of taste complaints.
Yeah. So I guess it's probably trying to tie together all those different data sources, right? So you'd have your sampling routine in terms of regular samples being taken, but then also you want to be able to link through any sort of taste and odour complaints that are coming from the public. So again, if someone rings up and says, hey, look, my water tastes a bit funny, that might be, again, a bit of an indication that you might have to do something sooner than your 2-week sample, for example, to, again, touch on that. And I guess we also looked in an early episode as well around what other sort of technologies might be able to be used, like spectros and other such sensors, which would give you those kind of early warning indicators.
And if you're in a great position where, you know, maybe you've got some pH monitoring, or, sort of even dissolved oxygen monitoring, or even fluorescence sensors coupled to your water supply, or maybe in your plant at some point, then you know, the great thing is when you've got sort of this data on the presence of cyanobacteria and you've got all of that other data, bringing them together and understanding what's changing with your high throughput data or high frequency data. And when we actually see cyanobacteria present is, you know, really great, because you've got these early warning indicators which says, okay, you know, we need to be on alert.
Something's changing,
Even, you know, if it's at a time when you might not expect cyanobacteria, because like John was saying, climate change is happening, and, you know, our weather patterns aren't going to be as predictable as they always have been. You know, things can get pushed later in the season, things can get moved up ahead. No,
exactly.
And a lot of suppliers are not going to have any information about their sources because the visibility on cyanobacteria in general has always been, you know, the big treatment plants, and potentially, you know, the maximum that a supplier might do is go down and have a look at the stream, you know, at best, with their eyes, which is fine, you know. Probably one of the best predictors or triggers for cyanobacteria monitoring is, you know, going and having a look and seeing the algae present, obviously. But it's more about what do you do next, and you know, and how frequently do you go and do those sort of things. Essentially, there needs to be if there is a risk, or an at-risk or a medium risk, there needs to be a plan. And that plan may say that, yes, you see it, you then take a sample of it, and you might do that once every week or every couple of weeks. You get a speciation test. That test comes back and says, yes, there are cyanotoxin-producing species in there, and then you start measuring for the toxins specifically. As Brett said, you might kick off one of your treatment processes. You know, so it's all about just having a staged approach to, you know, making sure that you can you've got enough visibility on the issue, be it with your eyes or some form of analyzer, that when stuff starts to change, you can follow through on a plan and minimise the risk of, harm to human health as much as possible.
And the reason you want that documented is so that you can respond to this, with big periods of time in between. You might not have cyanobacteria problems every single year, but if you have staff changeover in between and that person that knew what you should be doing has left, you want to be able to respond appropriately the next time round when something does pop up, and do the right actions and sort of not just be caught out and rushing around trying to get the advice to be able to respond appropriately.
And you also want to include all this data and the trends into a long-term plan and see what treatment processes you might need to incorporate, or if you need a new water source, and accounting for that with a good amount of time up front is the best way to do it.
Indeed.
So is there any options where, you've got a surprise cyanotoxin threat on your hands where you can sort of plug and play with water treatment, or is it the kind of thing that you need to be planning years in advance with?
Some of it can be quick, so quicker than others, such as installing a carbon dosing system, which will remove some of the risk. But there are some treatment plants we know of that have a UV disinfection system, which is powered for, say, advanced oxidation of some of these molecules of concern, particularly taste and odor, and potentially other similar organic molecules. And those ones will run at a lower level of UV disinfection. But when there's a risk, then they'll start dosing an oxidant such as hydrogen peroxide and increase the energy levels of that system. So they can respond very quickly, but if you don't have such a system in place, you need to be including that in your planning.
So that can be a real effective way, because a UV system plus, say, peroxide can be a much smaller footprint than, say, a filter. But depending on what your plan is like, any one of these technologies might be suitable. It really comes down to what's available, how much space you've got, things like that.
So I guess my sort of final question to close this out is, when does it become too expensive to look after your current source, and when does it make sense to perhaps look for another source? And I know that's quite an open-ended question, so just maybe some thoughts to sum up this episode.
I think you have to understand the risk and how much it would cost to treat the risk or minimize it at different parts of the process. And you might say, if you've got, say, a UV oxidation plant, why don't we run it all the time? But that can get very expensive from an operating perspective.
It can, and a treatment technology I didn't mention before when I was talking about it is chlorine. So chlorine, which gets dosed, which is effectively now mandated as a residual disinfectant, will, to a degree, get rid of some of the cyanotoxins. So the question is that in isolation enough? To really know, you need to know what kind of cyanotoxins might be present, because some of them will not be affected by chlorine. And then you have to have full confidence that the amount of chlorine that you're adding is going to be robust enough. Because an interruption of even, let's say 15 minutes in your chlorine, or a low residual or something like that, is that really enough of a barrier by itself? And then, of course, the final thing, which we've talked about in the other episodes to one degree or another, is often that the taste and odor accompanies these cyanotoxins, and they definitely do not get affected by chlorine. So if you have taste and odor issues, it really comes down to one and the same. The answer is that you should really have some sort of treatment.
So I guess it links into that whole idea of understanding your risk, and then based on that, you can sort out what your treatment technologies are, and then do that evaluation. So look, I think that's probably a good sort of background on mitigating the risk of cyanobacteria and cyanotoxins. So I want to thank you all for joining us today.